just a little bit, but I wanted to title this presentation Impact is Better Than Perfect, because I think that, especially in school, we have a very strong focus on being perfect with everything that we do, but oftentimes, especially in the development process, and also as times are changing, impact, particularly with sustainability, is becoming increasingly important. And I will roll that into talking about 3D printing as a key enabler for sustainability, such as the circular economy. All right, so as was mentioned, I graduated from Western in 2015, and these days I run a company called Animate Collective, which empowers change agents to grow, innovate, and invest in businesses that will shape future realities. And I have worked at various big logos, or worked with and at, most notably Starbucks, designed this 16-ounce ceramic tumbler with a swivel lid, which you've probably seen in stores. That was the first ID project that I had the opportunity to do after graduation. And I worked for a home goods company, designed a lot of things for gift stores, and helped introduce 3D printing to factories abroad. I also contributed to the Circular Economy for Dummies book, which I brought here today, and I've been featured in Forbes. So back when I was a kid, I was that Greta kid on the news locally, talking about trash cleanups and organizing tree plantings at my high school. I really loved sustainability, and my mom had me interview an engineer at Boeing who referred me to Marunas, actually. So I was really excited about the Western Design Program for the remade projects and focus on sustainability in the program, and the opportunity to combine my interest in business as well. I recently was on a podcast and I talked about Western. One of the great benefits of being here is that the education is so interdisciplinary, so it's really a strong opportunity to get involved with other departments at the university, just like you would in the real world. And one of those projects that I got to participate in here was the Solar Window project, which Emily at the back took over after I left university. So we originally started with one of these small prototypes and eventually built it into a 2 foot by 2 foot window and got EPA grants. And now it's actually a real thing, and those are the windows installed on the art building over yonder.
The colorful ones.
Yes, the color, yes. So they're testing different, I think, quantum dot strengths to see the energy production potential. Early in my career, I got hired to a home goods company here in Seattle, and that was where I had the opportunity to design a lot of products for Starbucks. And being in Western's program, you have an engineering education, and that makes you a very strong designer because you understand materials, hardware. You can actually go to factories and know how your product is going to be made. And that gave me the opportunity I got to go to China 3 times and lead an innovation residency. And some of the ideas that I came up with and worked on with the factories are still being used. I see them in Starbucks products still. When I was in factories though, I saw that there were some social and environmental issues, and being someone who was trying to design for sustainability, it was really hard to source, and I felt like software could help solve that problem. And so I decided to kind of pivot my career into the startup space and tried to do my own startup, the original iteration of Animate, which served to surface supply chain data for designers. And I envisioned a healthy material world. I discovered this concept called the circular economy, where we, like cradle to cradle design and life cycle thinking, we want to keep products in use as long as possible. I'll talk about that a little bit later in the presentation. I did learn I think one of the biggest learnings for me there, it didn't succeed, it didn't scale. I did learn that just because something exists in research and development doesn't mean that everyone knows about it yet. And that is kind of where I realized my passion for marketing and communications. I really want these technologies to be a success in the world, And so from that point, I then kind of kept going on the direction towards marketing in my career. I learned that I was really good at gathering community around these innovative technologies and launched the Women 3D Printing Meetup in Seattle. And this is the Makers of Seattle Winter Gathering, where we brought all of the different engineering communities together and showcased projects, and hopefully people became collaborators from there. With that recognition in the community and building my network, I got some recognition from emerging startups and got to work with larger companies like HP, NVIDIA, Google. From there, most recently at GE, where I was leading digital marketing, advising on a sustainability software product, and then also change management, which is helping organizations, using systems thinking to help organizations become more efficient or redesign how they operate. So I wanted to, the first part of this presentation, focus on impact being better than perfect, with an example of a product that was launched to solve the nation's nutrition and obesity challenges. So 10 years ago, 2013, juicing was the healthy lifestyle trend. And if we were designers, we might think, oh, this is a hot trend, let's launch a product for it. All these influential people are saying that it's gonna make you so healthy. And the internet was having search results that matched that. That led to the introduction of a product called Juicero, which with 3D printed renderings, which aren't a thing, I think the press didn't know what 3D printing was at the time, as well as a hot new subscription model and a smart IoT device. Investors said, this is perfect, we'll give you $120 million. We're also your best friends, so you don't need to talk to many people to get this approved. Let's go to market and hire a celebrity designer. However, 4 years later, once the product launched and people started using it, it was a massive failure, and it's still one of the biggest examples of Silicon Valley.
Bubble bursting.
Yeah. Silicon Valley imploding on itself. And they just didn't get the real market. When people started using it, it came with these packs that you had to scan into the machine. The machine was supposed to press these packs into juice, but people realized that you could just squeeze the pack and juice came out. So, The Real World, Designing for the Real World, that's actually a book, you should read it. Consumers do not have the patience for good stories to become good products. So, it's not as simple as just following a trend and launching a product, pitching to investors, getting a ton of money and following that trend. The shape of future realities, which I'm trying to design for, is complex. And I tried to kind of identify some trends here across different systems in our society and like where those trends are going. The highlights are kind of where Juicero may have been designing their product towards. I think they really kind of failed where they tried to make the most perfect design and most perfect product, but they were relying on social information. And as our upcoming generations who grew up with the internet know, we are in a wild information environment these days, and we're actually starting to create verified information trails and really believe in basing all of our decisions on science. So how do we design impactful solutions to complex problems? We use systems thinking. So if the designers and original engineer were to approach this from a systems thinking angle, they would likely want to make a map of the flows of information, recognize that people have a certain understanding about food. There's a political system that food exists in, and health system, and there's actual information about what is a nutritious food supply. And you might want to ask questions about who is lacking nutrition, and if we know that people who are in poverty are having the least access to nutrition, maybe we shouldn't design a luxury product that is intended to try and get them nutrition. We might want to recognize where there's friction that is blocking or diverting access to nutrition. And so we want to design interventions that would deliver the best nutrition and also serve as, in this case, people in poverty have the least access. So the government has actually stepped in and recognized, like, this is such a good idea, we're gonna help pay for it. And so there's now an opportunity in the food manufacturing space for freeze-dried manufacturers to become essentially like hubs for farming communities, where if there is waste or produce that overproduction, or even locally there's now smaller equipment, industrial design opportunity to immediately freeze-dry food waste and also retain the nutrients. So shifting now into the circular economy, this is a economic system that is starting to emerge. It has really taken off in Europe and is starting to take off here in the United States. A lot of these initiatives are being driven by regulation, but also design and engineering innovation. And one of those is the advancements made in 3D printing as an enabling technology. So a lot of you are familiar with FDM 3D printing, which is essentially like a hot glue gun helps form a product. And there's a picture here. There's lots of different kinds of 3D printing and even like full color 3D printing. And this is like biology printing, where we will actually be able to produce organs that live based from our actual cells. However, 3D printing, I want to emphasize, is just one technology within a smart manufacturing or advanced manufacturing space. And so we can have a lot of hype around a tool, but we want to recognize that this innovation can also apply to other tools such as robots and CNC. And what is the circular economy? The circular economy is a system that serves to capture and create value from waste by keeping resources, materials, and things in use as long as possible. It's emerged from several iterations of waste management, but you can see kind of every 20 years we've evolved. We can always think of new systems and change our systems. Everything in our society has been invented by someone at some point. So this idea started in the 1970s, and we actually used to have more circular systems. It's only been like since the 1950s of mass industry where we've started, like we used to put our milk cartons out, we used to repair our washing machines, but we moved to an economy where we just take resources, make something, and then throw it away. And so circular economy relies on tracing value and something called value stream mapping. And one element of value is capturing value, and so we minimize new resource use, and then creating value is when we maximize existing use and we can actually make money from that extended life. This is a really complex diagram. I made this with a client, and so this is an example of value stream mapping at a 3D printing manufacturer that is making prosthetic devices. When we map a value stream, we want to identify all of the people, processes, and technology involved in making that product. And all of those elements are going to help you determine how to design that product for an extended life in the circular economy facilitation network. You might also use this diagram process or systems mapping process to recognize where waste may be happening that you can capture and then turn into a product later on. And then there's also starting to be data through all these processes. So we can start to then recognize where waste is and then remarket it. So in production, there's a few ways that we can use 3D printing to help reduce waste. So generative modeling, I don't know if you guys do you guys have access to generative modeling here? So generative modeling is simulation software that I think Dassault Systems makes some, and so you may have designed a part like this, and then you can run it through the software and it will help meet the same functional properties with less material. And that is also called design for additive manufacturing. And you could even have better functional strength properties using this software.
With less material.
Yes, with less material. So you minimize the inputs. You can also, we're also starting to have intelligent material simulation where if we want to then start using recycled inputs because we're generating data about it, especially in the additive manufacturing space, we know how many times it has been recycled and therefore can calculate the material properties just like any standard raw material. Another way to minimize resource inputs, just like you might do at home to reduce your electricity bill, is using energy during off-peak hours. Another thing we want to do is rethink process waste. So I think 3D printing is really cool in that the companies that sell 3D printers, if there is like a build plate that you produce things on, they tend to have software that helps you optimize that build plate. And so when you're in a high production facility, you may create a schedule of production to maximize the use of that build plate and also maybe hold lower priority parts for those future builds. And that is important for reducing material use because once you use it, then you can't necessarily use it again. And in the prosthetic environment, there are medical regulations where you can't use it a second time. That will be improving with improved data about materials. Thinking about a product lifetime, I also think 3D printing is cool, just kind of like the machines are small and that kind of forces us to design modular, but it is also better to design modular in general because that enables, then you're designing for assembly, that enables disassembly of the object for repair or cleaning or maintenance, and then in the circular economy, there's starting to be whole product revenue models around enabling those services. So during the life of a product, we want to start thinking of products having a digital thread, and that digital thread is how we communicate with the customer throughout the lifetime of the product. And that can contain information such as 3D files that you might want to take to your local digital manufacturer to produce a repair part. It could also include the material information, and sometimes that might be proprietary, so you don't want everyone to be able to access that information, and software these days is, for example, able to give a recycler access to that, and then as the consumer, maybe you see more information about how to clean the product or where to donate it or even resell it in a marketplace. These digital threads also help the service partner network that is forming around care for products and the lifetime relationship with a brand. There's Viejo Shoes, for example, that is starting to have repair shops in their stores, and so encouraging people to continue coming back to your stores for these lifetime services may also help encourage them to continue purchasing things from your brand rather than changing their loyalties. These QR codes or barcodes, whatever method you may use, are even being tied to laws. So there's starting to be right to repair laws where you as a designer and engineer must design this object to be repaired. You've probably seen Apple come out with the repair kits for their phones, and that is a direct result of Europe implementing these laws. And, upgrade and remanufacture. I thought that fingers were an interesting example of this because traditionally when we design products, we want them to be as perfect as possible right from the start. However, there may be some products that we're continuing to innovate on, and when we think of an upgrade model, that means that we can launch this product now with the intent to continue upgrading it, and especially in prosthetics where limbs are such complex engineering objects, that is important to be able to, like, if we have a better finger, let's just put a better finger on.
Get your finger appointment, you're gonna get some new fingers today.
Yeah, and they fit on the model that you already have that is probably custom made for your arm, so we don't have to waste it.
Well, you have a file, your personal file for the dimensional, aspects and.
Yeah. And that's all stored in the digital passport. So end of life. doesn't exist anymore. Now we have material state transformation. So in the recycling space, if you've done research on it, you may have heard the term or thought of it as being something called closed loop, where this plastic can go through a recycling process and become the same plastic again. But unfortunately, the materials that we've designed in the past, we didn't design them to actually go through recycling processes. Recycling has kind of been a band-aid for us to continue producing and throwing these plastics away. The reality is that the material just degrades through a recycling process, and there's no recycle. There's only like upcycle or downcycle. Downcycle means that it's gonna have a reduced functionality or flexibility, and so in the case of plastics and things like glass, that is going to need to become a pressed object, like a plate, not a blown object like this container. However, there's an asterisk because there are innovative startup companies that have been able to start breaking down plastics into their base molecules, and then they can reassemble them at same or cheaper prices. I saw a startup present a couple weeks ago. We do need to recognize that it's going to take 5 to 10 years to kind of scale that technology, but it is cool that we should start to see recycling actually working. Waste to energy is another option other than trash, where we just heat it and we create steam and energy from that. However, we still have a lot of negative outputs in that process. So ultimately, we want to avoid these two options, but when a product is at ultimate end of life, avoid trash at all possible.